Okay, so last week was, actually a week from today was our Unit 2 test. Those have all made it to me. I have them graded and sent back to you. Um, just wanted to do a reminder that your contact person at your school should be giving you back a copy of your test and that you can do corrections. And to do corrections, you just redo any problems that you had correct, or incorrect, I should say. And make sure that when you do that, show your work, show every step. So if there's room, you can do it right on the test. If you need to use another sheet of paper, you can do that as well. Just get them submitted back to me through your contact person, or you can email them directly to me as an attachment at, of course, todd.hoff@northwoodtech. You are allowed to work together on corrections. You can work with other teachers, other students. Or if you need help, you can contact me and we can set up a private session like this that we can meet in Blue Jeans. I can help you through some of the problems if you can't figure them out. Any resources available to you for corrections. So make sure that before you resubmit those, be pretty sure that you have all those correct so that you can get back maximum points possible. Just for an example, let's say your score was a 72%. After corrections, that 72%, what is that, 28 would become an 86%. So it goes from being a D all the way up to being a B minus. So very important to do those corrections. Even if you've only missed a couple of points, redo those, get them back in by the end of the semester. Just a point or two could make a difference. Okay, enough of that. So we left off last Friday talking about our concentration adjustment formula, or change of concentration formula. And that was concentration 1 times volume 1 equals concentration 2 times volume 2. It could also appear as volume 1 times concentration 1 equals volume 2 times concentration 2. Exact same formulas, just set up a little bit differently. And the way they were utilized is, we might ask how much 3% solution can be made by diluting milliliters of 15% solution. So using our formula, C1V1 equals C2V2, we start out with our beginning concentration. That would be the 15%. I can either write it as 0.15 as a concentration, or I can leave it as a percent, as 15. Just whatever I do with that concentration, I have to do the same with the other one. And its volume is 60 milliliters. So 15 times 60 is the left side of my equation. On the right side, I want 3% for my concentration. Well, I left this one as percent, so I'm going to leave that as percent, as 3 times 2. And I can find my V2. What I'm looking for is how much. So 15 times 60 is 900. And we'll divide by 3. 300 equals V2. Now we need to make sure we put some units back on that. This was in milliliters, so this is 300 milliliters of that 3% solution. But we have talked a lot about these solutions and concentrations. I'm adjusting the concentration like this, using a dilution to reduce the concentration, like this. Find the concentration. If 24% solution goes through 3 and 8 dilution. We have a 3 and 8 dilution, the ratio of 3 to 8. And remember that dilution ratio is the same as our ratio of concentrations. Now 24, that is the concentrated, or the larger percent. That's going to go on bottom, and then we'll cross multiply and divide. 3 times 24 divided by 8 gives us 9% is our new concentration. That's what we're looking for. So we've looked at these concentrations a lot. Today I want to take a little time, step back, and look at how do we calculate concentration. This is not as simple as it might look, because when we're dealing with solutions, certain things are not additive. Additive means if I combine 20 milligrams of one substance, 30 milligrams of another substance, the result, 50 milligrams. Well, that is actually one thing that is additive, is mass. If I add two things together, the total mass of that mixture or solution is just the total of the two masses added together, the two individual masses. But one thing that is not necessarily additive volume. We look at dissolving something. Let's do salt and water. If I have 80 milliliters of water and add to it 5 milliliters of salt, you would expect the resulting volume to be 85 milliliters. However, it is not. Because with volume, it depends on space between particles. Even though water's a liquid, there's still space between the water particles. Those particles are in loose chains throughout the liquid. It looks something like that. And when we add salt to it, the salt part, the reason salt dissolves into water, because it's able to fit into those gaps between particles. Now, it doesn't necessarily fit in there perfectly. It might push the particles a little bit further apart. But if we add 5 milliliters of salt to 80 milliliters of water, the result is going to be somewhere around 82 milliliters of salt water. So volume is not additive. And of course, volume, when it's a problem for adding a powder, water, so like salt or sugar or any sort of powdered medication going into water, that volume will not be additive. Or some sort of non-water-based solution. Most of us think as solutions as being a powder, salt, sugar, whatever, dissolved into water, but it actually, you can have another liquid dissolved into water. Alcohol, rubbing alcohol will actually dissolve into water and stay mixed. Alcohol does the same thing as the salt does. It fits between the particles of the water. Where it is not a problem, and where it's okay, is when it's two water-based solutions. If I am combining 30 milliliters of a 4% solution with 20 milliliters of a 9% solution, if those are serum dissolved into water, typically that will be additive. That will be 50 milliliters total solution. So there it is additive because they are both water-based. And the solute is a small enough portion of it, it doesn't affect the total volume. Anyway, let's look at our percent solutions. So the first way that we calculate a concentration is called a weight in weight. Now, typically it's abbreviated W/W. This is an old terminology. It actually comes from the standard system, the customary system, where it was pounds into or ounces into pounds or whatever, where we were using weight units. In the metric system, we're using grams and kilograms, so technically those are mass units. It should be changed to mass in mass, but we keep that notation W and W, or weight and weight, just out of tradition. But typically the weight and weight solution will be the mass units of the solute or we'll still use unit weights of our serum over out of 100 unit weights of total solution. Notice this is total solution, although it will be additive. So if I have, find the concentration if 20 milligrams of serum dissolved into 160 milligrams we have 20 milligrams of our serum or solute out of 160 milligrams total solution. Now it's very important that these units match up, so the milligrams cancel out. 20 over 160, if I divide that out, is 0.125. So that is our concentration as a rate. Convert that to a percent. Of course, we multiply by 100 or move the decimal point over. 12.5% solution, weight in weight. I might ask you, find the weight and weight concentration if milligrams of serum find 360 milligrams of NS. So there's a slight difference here. Up in this top one, I gave you the amount of total solution. This, I gave you the amount of serum and the amount of saline or sterile water it's being mixed with. Find that concentration. Have the 40 milligrams of serum that goes on top, but on bottom we need the weight or mass of the total solution. So it's the 360 milligrams of saline plus the 40 milligrams of serum. So once we've added those, we have 40 milligrams 400 milligrams. Milligrams cancel out. 40 divided by 400 is 0.1. Again, that's as a rate. Convert that to a percent, that would be a 10% solution. We might ask how much 12% weight and weight solution can be constituted using 30 syrup. So here we're going to look at 12%. Now we're going to write that as 12 out of 100, just like we did back when we were doing our percents in Unit 1 and Unit 2. The other side, of course, the top number is still the amount of serum. That's our 30 milligrams. Bottom number, for the total solution, cross multiply and divide. 100 times 30 divided by 12. Just 250 milligrams. Now we need to make sure this is answering our question. We look up here and it is. We wanted to know how much of that solution, 250 milligrams, is the amount of that 12% solution. Next, we have volume and volume. Again, abbreviated V/V. So we're measuring the volume of our serum and the volume of our total solution. So let's say here that we have find the concentration if 400 milliliters of solution contains 60 milliliters serum. Oh, it's the volume of the serum, 60 milliliters, over the total volume of the solution, 400 milliliters. Once again, the milliliters cancel out. 60 divided by 400 should give us 15.15, I should say. That's our rate. And of course, as a percent, that would be 15%. Like I said, volume and volume you have to be a little bit more careful with. I can't just say I'm going to take so much water or saline and add it to my medication unless I know that that medication is additive with water. If it's in a liquid form, if it's powdered, it's almost never additive. I mean, in a liquid form with a similar density or consistency as water, then they can mix with an additive volume. We have to be very careful with that up here where we had the amount of serum mixed with a certain amount of saline. We were able to add the serum and saline to get a total mass or total weight, not do that with volume. Finally, we're going to look at weight in volume concentration, abbreviated W/V. Now again, since we're using metric systems in most medical situations, this really should be a mass in volume. But the one key that we need to remember here, and all these others, since it was mass and mass, or weight and weight, and volume, we said to make sure we use the same units. Here, since it's weight in volume, we have to make sure we have the appropriate units for each. And the units that mix together, and this surprises people. 1 gram, remember, equivalent to 1 milliliter of water. That's the definition of a gram. So when we're dealing with a weight in volume solution, our weight needs to be measured in grams. For our serum, but our volume in milliliters for our total solution. This is typically a much better concentration when we're dealing with putting a powder into a liquid carrier, because volume is not additive in that case. If we do a weight in volume concentration, it's just way easier to avoid making the mistake of trying to add volumes. I might have find the concentration, find the weight in volume concentration. If 30 grams of serum dissolved in 120 milliliters of total solution. So again, we need our weight or mass of serum, that's 30 grams, and our volume of our total solution in milliliters, that's 120 milliliters. I divide that out. 30 divided by 120 is 0.5, or what would be listed as 25%. More often than not, this type of a concentration, rather than being listed as a percent, is going to be given like this. It's 0.25 grams per milliliter. Or, don't like small decimals like that, it might be converted to 250 milligrams per milliliter. That's a pretty high concentration, by the way. Okay, so let's go back through some calculation examples here. Let's find the weight and weight concentration. If 800 milligrams of serum is combined with grams of sterile water, normal saline. So we start off with this. Again, the amount of our serum, the 800 milligrams, over the total solution, plus the 3.2 grams of saline, plus 800 milligrams of serum. Well, we have an issue here because we have different units. These are in milligrams, and this is in grams. We're going to do a unit conversion here. We're going to keep that in milligrams. We're going to go 3.2 grams is 3,200 milligrams plus 800 milligrams. Now it's 800 milligrams over 3,200 plus 800 is 4,000 milligrams. Units are the same. We can cancel those out. 800 divided by 4,000 is 0.2% solution. Here's the one that I catch a lot of people on. Find the latent volume concentration if 20 milligrams of serum is in, well, let's go 80 milliliters So we're going to set this up. We've got our amount of serum is 20 milligrams. Total solution is 80 milliliters. Looks great at first until you remember that our comparison for weight and volume is always weight in grams to volume in milliliters. So before we can divide this out, we have to make that conversion. 20 milligrams is 0.02 grams for 80 milliliters. Now we can divide that out. 0.02 divided by 80 gives us, now if your calculator does this to you, I'm glad this came out like this, it's 2.5 e negative 4. What the calculator is doing is putting your number into scientific notation. This is saying 2.5 times 10 to the negative 4th. This is one of the reasons why we took the time to go over scientific notation in the last year. Because some of our very low concentration calculations will come out like this. So that 10 to the negative 4th means I take that decimal point and I move it 4 spots to the left. Adding zeros, 0.00025 is my concentration. I still have to turn it into a percent. I move the decimal over 2 spots. That's a 0.025% concentration. And again, the reason for such a low concentration is because we were measuring our serum in milligrams, and for a weight and volume concentration, it does have to be grams into milliliters. I'm going to switch gears just a little bit, and we're going to talk about syringes. Of course, this is really a discussion about measurement. And scales. So when we look at a syringe, first we need to know what unit it's in. So typically it'll be labeled milliliters, either at the end towards the needle or at the end towards the plunger. Of course, as the plunger slides in and out, it's going to stop somewhere. Let's say it stops right here is where our plunger stops. So of course it'll be this side, the front side, the side closest to the needle. That's where our measurement is taken. Now, we need a lot more information to figure out how to read this. Let's say that this is 10, 20, 30, 40, 50, 60 milliliters. Figure out the scale of a syringe. We take 2 spots that are labeled. We try to skip this first spot because a lot of times up here this is actually tapered. So those first markings are a little tough to see. Let's go from here to here. So that's from 10 to 20. So that's 20 milliliters minus 10 milliliters. And then we count the number of spaces between those markings. 1, 2, 3, 4, 5 spaces. So we'll go ahead and subtract. 20 minus 10 is 10 milliliters over 5 spaces. That means it's 2 milliliters per space on that syringe. So that scale is 2 milliliters per space. So then to find the volume in that syringe, we find the closest marked spot, that's the 60 here, and we can count up from there. Each space is 2 milliliters. This will be 62, 64. That syringe is about 64 milliliters. Let's say this syringe is marked milliliters. Oops. Also marked milliliters. But let's say this one is marked 1, 2, like that. And once again, we'll put our line, and we'll do it like right here. That's where our plunger is coming to. So again, first thing we need to do is figure out what each division is worth here. So we look at two marked spots. Well, we've got the 1 milliliter and 2 milliliters. That's 2 milliliters minus 1 milliliter. And we look at how many spaces are between them. Well, we can cheat a little bit here. We know this is 1, 2, 3, 4, 5, and then we can just count them in clumps. That's 5, 10, 15, 20. There's 20 spaces between those. So we subtract 2 milliliters minus 1 milliliter is 1 milliliter divided by 20. Well, 1 milliliter divided by 20 spaces is 0.05 milliliters per space. So as we go to find this, we're going to count up 1 milliliter, 0.05, 0.10, 0.15, 0.20, 0.25. Well, we can see that every 5 spaces is 0.25, so we could use that, or we could just keep counting 0.30, 0.35, 0.40, 0.45, 0.50. So that's 1.50. 55, 60, 65, 70, 75, so 1.75. 80, 85, 90, 95. That's 1.95 milliliters of fluid in that syringe. So it's important to be able to determine that scale from the markings on the syringe. So let's say that this one is marked 1, 2, 3, 4, and it is filled. Let's go right to here. I'm going to give you a minute or so in your notes to look at that and figure out just how full that syringe is. So again, we'll go between consecutive markings. This is 1 milliliter and 2 milliliters. Milliliters minus 1 milliliter, and we count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. 2 milliliters minus 1 milliliter is 1 milliliter, divided by 10 spaces, is 0.1 milliliters per space. Then again, we started a marked spot with 3 milliliters. This would be 0.1, 0.2, 0.3, so that's 3.3 milliliters is what is in that syringe currently. What if our syringe is marked cc's, and let's say that this is numbered, 1, 2, 3, 5, 6, 7, 8. And we'll have it full here. Well, first of all, cc's stands for cubic centimeter, centimeter cubed. And remember, 1 cc, 1 cubic centimeter, is the definition of a milliliter. So they're the same thing. cc's or milliliters, exactly the same thing. So now our process is going to be the exact same. We've got 1 milliliter to 2 milliliters, or 1 cc to 2 cc. Milliliters minus 1 milliliter. There's 1, 2, 3, 4, 5 spaces in between. 2 minus 1 is 1 milliliter, divided by 5, 0.2 milliliters per space. So again, we look at the nearest marked one is the 6. This would be 6.2, 6.4 milliliters, or 6.4 cubic centimeters, however you prefer to state that. But with that said, let's take a look at 2 syringes. Now, I'm going to call this one, let's see, 1, 2. This one here labeled like that. And I need 2.1 milliliters of medication, of fluid, to be administered to the patient in these syringes. Well, first of all, there's something a little deceiving here. If these markings are different scales like this, what would be different is this syringe here where the markings are tighter together, where it has a higher volume, that syringe would actually be wider than the other one. It would be fatter. Now that width is significant because that means that from here to here, one spacing on the syringe is more volume, just like we figured out. Up here, we go from 1 to 2, so 2 milliliters minus 1 milliliter, over, there are 20 spaces there. That's 0.05 milliliters per space. Down here from 1 to 2, that'd be 2 milliliters minus 1 milliliter. There's only 10 spaces between there. That is 0.1 milliliter per space. If I need 2.1 milliliters, my first question is this smaller syringe, is it big enough? And yes, we can get up to 2.1. 2.1 would be right here on that smaller syringe. On the bigger syringe, 2.1 would be right here. So you might be thinking, what does it matter? I can use either one. Both of them will hold 2.1 milliliters of fluid. But remember, each spacing, these spacings are the same distance apart on the syringes. Each spacing has a different volume to it. And when we are filling a syringe, there is human error. We might not get it exactly on that 2.1 line. If we slightly overfill like that, we're slightly past the line, or we might slightly underfill like this, where we're just a little short of the line. If we're using the smaller, narrower syringe, the one that has a lesser total volume, that little bit that we're off from the line is a smaller amount. We can be off by one full space here, and it's only 0.05 milliliters. Whereas down here, it would be twice that, 0.1 milliliters. So we want to use, when we load up a medication in a syringe, we would like to use the smallest syringe possible that is still capable of holding the total volume necessary to administer to the patient. And it's just for that reason, of that slight human error. If you're slightly off of being exactly on the mark, that narrower syringe is going to be less volume of error compared to the wider syringe. Now, with that said, because it is so hard to fill syringes, we're not going to be looking at filling syringes or coloring in the syringes to fill them. Mostly, we're just going to be looking at reading a syringe and figuring out what volume it actually contains. But if you can read a syringe, you should be able to fill a syringe as well. With that, out of your book, page 146, 1 through 17, we'll just have you work on the odds there. That's only 9 problems. That is our percent solutions, the weight and weight, volume and volume, or weight and volume solutions. And then on page 168, 169, 1 through 19, the odds. Those are the syringes. So go through those and see if you can read the syringes, figure out how much each of them is holding. We are about 5 minutes early today, but I want to make sure you have time. Have you guys got your tests back? And does anybody have any questions on test 2 that they'd like me to go over that they can't figure out? Not hearing anybody, so that either means there's no questions or you have your mic muted. I will let you guys go if you guys want. I realize most of you, this is your lunch period anyway, so we'll let you guys go a couple minutes early today. I will stay on the network for a while here if anybody does have any questions on their test that they would like to ask. Otherwise, you guys have a great day, and hopefully we'll see you all on Wednesday.
Do you guys have a spring break?
We do. It's actually next week.
Okay, because ours is April 11th through the 15th.
I was looking at that. I saw that. So we're going to have to do some working around it. Let me grab my calendar here quick. Yeah, so let's see here. Oh, so you have that whole week off. I just had you guys down for Monday and Friday that week. But you do have the whole week off. Okay, so let me. What we have is Clear Lake is next week is their spring break. Austin is the week after that, and you guys are back at Easter. So what we're probably going to do, and Durand is dropped, they're out of the picture, so I don't have to worry about Durand. So what we'll do is there won't be class next week, but I will have everything posted on Blackboard up to date. So you can see week 9, which would be the material that would be the week after that. That'll be from Austin, not for Clayton, I guess. So Austin will be able to work ahead while they're gone. What we'll probably do is, since everybody is gone at least that Friday, the 15th of April, we might take one of those other 2 days off as well. So if you guys miss one class, we'll use that as a review day.
That sounds good.
Okay, we'll make it work so you don't miss too much.
Next coming.
You guys have a great day.
You
too. See ya.
Thanks.